Hello everyone, my name is Chai Chong Kai from Group 11. My group members are Alex Ting, Ang Wei Ying, Chang Xiang Wei, Hong Yujun, Hisfarira, John Law, and William. Today we want to present the modeling of impulse transient using the lightning method. First, I want to describe the lightning strike. A lightning strike is a natural phenomenon and each strike contains about 300 million baud and about 30,000 ampere. Lightning strike will cause transient overvoltage that often lead to failure and damage to electrical system. During lightning strike, electrical energy is released rapidly, producing transient pulse characterized by high voltage and current. These transients have the potential to cause equipment failure, insulation breakdown, and power interruption. Next is impulse transient. Impulse transient always occur suddenly and have high energy. These transients are short in duration and large in amplitude and can have serious effect if not managed properly. Lightning strike, switching operation, and short circuit are just a few examples of the different causes of impulse transient. Next, I want to pass my talk to Hong Yujun.
Hello, my name is Hong Yujun. I will going to present the scope of assignment. Our scope of assignment is do some study about how lightning strikes affect electrical system. We do some research and relevant information about the wave of lightning current, peak current value, properties of lightning channel. Besides that, we also focus on the governing grounding surge protection system in the reducing lightning strikes. The optimized solution will be recommended. Our main focus is improving performance and protection of electrical system from lightning strikes through modeling, simulation, analysis, and making recommendations. Our project purpose statement is to address the requirement for accurate modeling and analysis of impulse transient induced by lightning strike in electrical system. This is because the lightning strike that will cause impulse transient can damage the power lines, causing equipment failure, blackouts, and safety hazards. Next is the objective of our project. Our project is to develop a comprehensive model for simulating the behavior of impulse transient induced by the lightning strikes, and to accurately reflect the behavior of lightning-induced transients and include pertinent lightning parameters in simulating model, such as stroke current waveform, peak current magnitude, and lightning channel properties.
This is the power system model that we built to simulate the impulse transient caused by lightning. This model consists of one MVA source feeder supplying 400 volts to the bus, and a three-phase load is connected to the bus. Each phase of the load is the combination of resistive and inductive load. And a voltmeter is also connected to the bus to measure the instantaneous voltage waveform of the bus. The lightning model is connected to each phase of the power line in order to introduce lightning strike. This lightning block is built by mathematical function, which will be explained later.
Alright, hello everyone, my name is John. So today I'll be presenting about the methodology. So this presentation will cover the report part 3.2, which is the lightning block subsystem. So the lightning block subsystem is as shown in this figure. So the lightning we will connect it to phase A, phase B, and phase C. So here we apply the lightning impulse to each of the phase in the simulation MATLAB. Now, how do we model this lightning is that we use a mathematical function, which is Vt equal to A exponential the power of negative alpha t minus t1 times ut minus t1. And by definition, A is the magnitude of lightning impulse, alpha is the damping factor, t1 is where we commence the impulse, and t is the function variable time, and lastly is ut minus t1 is the impulse step function rises from t1. So how do we apply this into MATLAB is can be shown in this figure below here. This is how we apply the mathematical function into MATLAB. Now for the function block, we have 4 function blocks, which are the ramp block, the constant block, the t1 block, and the step function block. So the ramp block is the time function, and the constant block is where we can key in the perimeter for the magnitude. And t1 is the impulse commencing time. This is when we want to start the lightning impulse, and lastly is the step function block, which is for step rising. And these are the perimeters for the lightning impulse in the simulation. So the signal amplitude A is equal to 1000, the impulse start time is 0.012 second, and the damping factor alpha is 14,000. So as a result, the lightning impulse equation becomes 1000 exponential negative 14,000 t minus 0.012 times by ut minus 0.012. So this is the equation for the perimeters above here. And as a result, the lightning impulse waveform will be as shown as here. So how do we verify that whether this is the equation here is the lightning impulse waveform is that we can perform two calculations, which is at 0.012 second and at 50% of Vt. So firstly, at t equal to 0.012 second, we will get the voltage is at 1000 volt. And at 50%, which is half of 1000 volt, that is equal to 5000 volt. So if we perform a series of calculation, the time when the voltage is 500 is 0.01205 second. And this is proven by this lightning impulse waveform here as shown in this presentation. So as we can see at 0.012, the magnitude of the lightning is 1000, and at 50% of it, this happened at 0.01205, and this are proven in the calculation here. So this shows that our equation for lightning impulse work, and for this waveform, the waveform is also according to the IEEE standard, IEEE definition for the lightning impulse. So this covers the methodology of the lightning block subsystem. So this is basically how we create the lightning impulse in MATLAB simulation. So I guess that's the end of this presentation. Thank you.
Hello, my name is Chiang Wei, and I will present the part of the result. So this is the normal three-phase power system without any interference of the lightning. We set the input voltage source as 400 watt. As you can see in the figure, the peak of the amplitude remained 325 watt due to the voltage drop in the transmission line that introduced resistance. So it means the longer the distance or the higher the current, the greater the voltage drop.
Hello, my name is Hisfawira bin Hamdi, and now I'm going to continue to present the result from our simulation. As we can see from the graph, each phase has different amplitude, but when the lightning enter the power system at the time between 0.01 second and 0.015 second, each phase has different impulsive transient amplitude. As we can see from these three graphs, the voltage rise instantaneously until 1200 volt for every phase. That's all. I'm going to pass the presentation to the next presenter.
So thanks Sifa for the simply brief, and I will explain more a bit. According to this figure, it is a phase 1 voltage. We can observe that the voltage at 0.02 second is recorded at a magnitude of 118 kilowatt, which undergo an impulsive transient such reaching of a peak value of 792 watt. So the same situation is in the phase 2. Initial the absence of the interference, the voltage stand at a level of 324 kilowatt. However, when subjected to the influence of the lightning, it undergoes a significant surge, soaring to a magnitude of 1247 kilowatt. So in this figure, the phase 3 voltage is originating from an initial voltage of negative 134 kilowatt. After the presence of the lightning interference, it propagates the voltage to 760 kilowatt. After the observation of the three-phase voltage, we can conclude and understand the lightning caused a surge that occur within very short duration of 1.2 microsecond, and followed by the reduction where the peak value decreased by 50% within 50 microsecond. Moreover, we also notice a slight overshoot in the voltage before it reached a stable state. So this behavior is called damped oscillation, where the system exhibits oscillatory movement around the steady state before eventually settling down, which means the voltage fluctuated briefly before finding a balanced state. So that's all for me. Thank you.
In conclusion, an essential component of electrical engineering that permits the evaluation of system performance and dependability during lightning-induced events is the modeling of impulse transients using the lightning technique. We may model and analyze how electrical systems react to lightning transient using equivalent circuits, specialized impulse generator, and voltage measurements. The modeling study enables a thorough comprehension of impulse transient properties, including peak amplitudes, duration, and waveform shapes. This knowledge is crucial for us to determine the system vulnerability to lightning strikes and developing suitable safety precautions. By using the simulation software, it is possible to assess system behavior, spot potential problems, and create the necessary safeguard and mitigating actions to protect the system from the negative impacts of lightning-induced transient. Such methods as surge arrestor, shielding, grounding, and insulation coordination may be used. That is all for me. Thank you.
And then for our references is from tension analysis blending system for one turbine, and then lightning electromagnetics, type of lightning strike, harmful effect of lightning, and then the influence of lightning induced voltage on the distribution line polymer insulator. And then the next one is electromagnetic tension analysis and protective relaying techniques for the power transformers. The next one is understanding the interaction between lightning and power transmission lines. Next is lightning-induced transient effect in a hybrid PV1 system and mitigation strategies. And then lightning physics and effect. And then impact of the time parameter of lightning impulse on the breakdown characteristic of oil paper insulation. And then next is from electrical tension sources, waveform, and mitigation tips. Next is high current field test of impulse tension, characteristic of substation grounding grid. And then from the simplified modeling of an aircraft vector for lightning impulse tension studies. And then from impulse tension in the power system. And then from non-iterative technique for determination of full lightning impulse voltage parameter. And then the last one is from the transient in solar photovoltaic system during lightning strike to a transmission line. Thank you.